Okay, today we're talking about exponential functions and equations. So first of all, this is a quick review on the laws of exponents. You want to write these down because you need to use them throughout the lesson, okay? And going forward, you need to know these as well. And we're not going to give you examples on these because the lesson itself is pretty long. So you also learned this in Algebra 2, right? So we're going to assume that you know this. If you don't remember, there's always office hours or ask questions in class, okay? But you need to know this throughout the lesson today and going forward. So we're talking about exponential functions. And so the most basic form of an exponential function is this, like f of x is equal to a to the x. A is a number and x is your x variable. Okay, so there are two cases. The first one is when a is greater than 1. For example, I have f of x is equal to 2 to the x. So a is 2 now in this case, right? So it's greater than 1. And so we want to really understand how this works. So let's fill out this table. And I'm going to start with 0. I'm going to put that at the center because I want some negative x as well, right? So if I put 0 in for x, 2 to the 0, anything to the 0 power is 1, right? So that's, again, law of exponents. You got to know that. Anything to the 0 is 1. So that point is always on there, no matter if it's 2 to the x or 100 to the x, anything to the x, when x is 0, it's going to be 1. And then you put 1 in, you get 2 to the first power, which is 2. And you put 2 in, you get 4. Put 3 in, you get 8. Okay? So that's just the exponents. When you put x in, you get those numbers for y. Put negative 1 in for x. 2 to the negative 1. What does negative exponent do? It means you divide. So it's 1 divided by 2. It's 1/2. Right? How about 2 to the negative second power? So it's 1 over 2 squared. So dividing by 2 squared, which is 1/4. All right, so if you plot that on the graph, you get this kind of graph, right? So this is the graph of 2 to the x. And just a few properties of this graph here. You know the point 0, 1, it's always going to be there. No matter what the number is. Like if it's 2 to the x or 1,000 to the x, it's always going to be 0, 1. Because anything to the 0 power is 1. When a is greater than 1, it's called the growth factor because this is the growth function. This function is called exponential growth. Okay. So this function is called the exponential growth, or increasing function. The domain of an exponential function is always all real numbers, always. So you don't have to worry about domain, always all real numbers. The range, in this case, the range, you kind of have to look at the graph, and it starts at 0 here. See, you got to imagine now, if I go further to the left, like if I put really big negative number in for x, it's still going to be 1 over something. It's going to be 1 over a really big number. So it gets really close to 0, but does not touch 0. Right? So the range is above 0. Okay? Y is larger than 0. And we have the horizontal asymptote at y equals to 0. Okay? So if you want to try and plug in a really big negative number for x, like negative 100, 2 to negative 100, it gets really close to 0, but it doesn't get to 0 because it's 1 over something. When you graph these, there are 3 important points that you want to know every single time. Okay, it's negative 1 and 1 over a. Okay, so imagine if x is negative 1, you get 1 over a. In this case, is 1/2, right? Because negative 1 means you divide by that number. So 1 over 2. So in this case, we have 1 over 2, right? And the 0, 1 is always going to be there. And then when you have 1, you have just a, because 2 to the first power is just 2, right? 1 and 2, that point here. So you know these 3 points because every time you graph, we're going to ask you to know these 3 points. So the formula is negative 1, 1 over a, 0, 1, and then 1a. So these are the 3 points that gives you the shape of the graph. So you're like, oh, it goes up like that. The second case is when a is less than 1 and greater than 0. A can never be negative, okay? So we're not going to talk about a being negative because that's a discontinuous function. So here, a is 1/3. So it's between 0 and 1. And let's put in the point, right? If we put 0 in, anything to the 0 is 1. So I still have 0, 1 as my point. And then if you put 1 in, you get 1/3. 2, you get 1/3 squared, which is 1/9. 3, you get 1/3 cubed, which is 1/27. You put -1. Negative means you divide. 1 divided by 1/3 is 3. Okay, it's like you're flipping it. -2, you get 9, right? You flip 1/3, you get 3. 3 squared is 9. Again, law of exponents, very important. So this is the graph. It looks like this. It goes down. And here, the three important points are -1 and 1 over a, right? You guys remember 1 over a is, in this case, 1 over 1/3, which is 3. -1, 3. You see, 1 divided by 1/3 is 3. We have -1, 3. 0, 1, again, is always there. And 1 and 1/3. See, these are the 3 points that give you the shape of the graph. Okay, again, they approach y equals 0. So there's a horizontal asymptote at 0. But this one is called decay. Now, don't think that it's going down that makes it decay. Decay means that the change between the 2 points here. You see how it gets really closer and closer and closer together. If I put another point here at 2, the change in the height is very short now. It flattens out. So if you look at the graph and when you go toward the right, if the graph flattens out, it's decay. Whereas if it gets really steep, then it's growth. Okay, it doesn't matter if it's going up or down. As long as it's flat, it's decay. If it's steep, it's growth. So this one is called decay because it's really getting flat as you go to the right. Okay, or we can call this a decreasing function. All right, the domain is all real numbers, again, always. And the range is y is larger than 0. And we have the horizontal asymptote at y is equal to 0. Now we have to talk about the transformations because we got a graph like all different types of equation, right? Not just the basic. So the transformations are these, right? I put them in different colors, and you have to do them in order. Okay, so the first one you always do is the one next to x, right? In the parentheses, subtracting or adding h. So h is the horizontal translation. So if it's negative, you go to the right. If positive, you go to the left. Things like that. Right? You guys know this. The next one you would do is b. B gives you the horizontal reflection and the stretch or compression, okay? But we're not talking about the compression too much or stretch, okay, for horizontal. So you guys don't have to worry about that. Just worry about the reflection, the horizontal reflection. If B is a negative number, it reflects sideways, okay? Then you go to the C. C is a vertical reflection and a stretch or compression. So you got to do both. For vertical, you got to know. If it's stretch or compression, you got to know that. Okay, and if it's negative, you reflect it down across the x-axis. Okay, and the K is the vertical translation, so you move up or down. All right, remember these have to be in order. So let's try some graphs. Okay, here's the equation. I have fx is equal to -2x. So let's look at the transformations here. What are the numbers that we're putting in here? So negative out there, it's not -2 raised to the x, okay? The number 2 itself is not negative. It's a positive 2 raised to the x, and then you multiply by -1. So c is -1, okay? In this case, c is -1. Now, the parent function, of course, is 2 to the x. And since a is greater than 1, this graph is going to be a growth. But after the transformation, it might change. So you got to just look at the graph to see if it's growth or decay. All right? The three important points are, remember the formula, -1 and 1 over a, 0, 1, and 1a. So in this case, I have -1 and 1 over 2. 0, 1, and 1, 2. Okay, I'm going to plot that on the graph. Looks like that. Okay, -1, 1/2, 0, 1, and then 1 and 2. And then the horizontal asymptote, again, is y is equal to 0. So I have the shape of my graph already. I know it's going to go up like that, right? So it goes up. There's the graph. That's my parent function. Then I'm going to apply the transformation. The c is -1 means there is a vertical reflection. There's no stretch, no compression because it's 1. It doesn't stretch or compress, right? So reflects downward across the x-axis. Okay, so imagine now this graph goes up like this. Now it has to go down. What is changing in my points? This is the hardest part of this graph. You have to think about this. If it goes down, what is changing with the coordinates of these points? These points go down here. The x values don't change. The y values become negatives. Okay, because it's going down below the x-axis now. So if you have a vertical reflection, you change your y values to their negatives, to their opposites. So my points are now -1, -1/2 now, okay? 0, -1, and 1, -2, because vertical reflection changed the y values to the negatives. So my points are down here now, okay? Instead of up here, they're down here. And the reflection does not change the asymptote, right? The asymptote is still there. So the asymptote is still the same. And now I have my graph. It just reflects downward. Again, the domain is always all real numbers. The range now, my graph is underneath. So y is less than 0. Y is less than 0. Okay, and this one is still growth. Look, it's getting really steep. You see, this is steep. This graph is also steep. Even though it's going up and this one is going down, they are both exponential growth. This one is negative growth. This one is positive growth. Another one. Here I have 3 minus x plus 5. And I put in here and compare what are the transformations. Negative x means -1 times x. The 5 in the back is the k. Okay, so the parent function is just 3 to the x. Right? Again, this one is the growth because, 3 is greater than 1. And my points, again, I'm writing out the formulas. You guys should know this formula. -1, 1 over a. So it's -1, 1 over 3. 0, 1 is always there. And 1, comma 3. A is 3 in this case. Okay. So my points, I'm plotting out here. -1, 1/3, 0, 1, and 1, 3. And then the horizontal asymptote, again, is y is equal to 3. I mean 0. So there is my horizontal asymptote. And I get the shape of my graph. I know it goes up this way. So it curves. Okay, that's my parent function. Now, I apply the transformations. B is -1. It means there's a horizontal reflection. It reflects sideways. And the 5 means it shifts up 5 units. Now, you got to think about this. If there's a horizontal reflection, does it change your x or your y? How does it affect your coordinates? If it reflects sideways, okay, sideways, that means your x values becomes their negatives. Okay, so my first point here, -1, it would be +1 and 1/3. Okay, but then I also shift up 5. That means my y values go up by 5. I add 5 to the y values. Okay, so two things. My x values become their negatives. My y values, I add 5. So my 3 points, see, -1, the x value becomes +1. The y values, I add 5 to it. So 1/3 plus 5 is 5 and 1/3. 0 here, the x value, it doesn't change, right? Reflection, negative of 0 is still negative. It stays there. However, the y values, you add 5. So 1 plus 5 is 6. The positive one here becomes -1. 3 plus 5 is 8. So I get these 3 points. And I plot them. They look like that. Now the horizontal asymptote, that gets changed because you shift everything up by 5. So the horizontal asymptote is now y is equal to 5. There is my horizontal asymptote. Now I know the shape of my graph. It goes along here. So there's my graph. Domain, again, is always all real numbers. Range is y is larger than 5. Last graphing problem. Here, my transformations are the 2 in front and the -4 in the back. And the parent function is 1/3 to the x. In this case, this is a decay, right? Because 1/3 is less than 1. So it's exponential decay. The 3 important points. Again, the formula is here. I get -1. 1 over 1/3 is 3. 0, 1. And then 1 comma a. A is 1/3. Okay? So there are my points. My y asymptote is y is equal to 0. And I know my graph goes like that. That's my parent function. Now I do the transformations. The 2 is a vertical stretch of 2. No reflection because it's positive. -4 means you shift down 4. So again, vertical stretch of 2, you got to know what that does. It's stretching upwards, right? So my y values gets multiplied by 2. Y values get multiplied by 2. And then shift down means my y values then subtract by 4. The x values, in this case, they don't change. So the 3 important points. I'm going to take the first one. Again, the x does not change. I have -1 stays the same. The 3, I got to multiply by 2 because the stretch of 2. So 3 times 2 is 6. Minus 4 is 2. So -1, 2. 0, comma 1. 1 times 2 is 2. Minus 4 is -2. 1/3 times 2 is 2/3. Minus 4 is -3 and 1/3. So I get my 3 points. That is the hardest part. You guys got to keep a lot of things in mind. You should write it out if you need to, okay? Take the y times 2, subtract 4. So these are my points now, okay? Now my horizontal asymptote, I shift everything down 4, so my horizontal asymptote goes down by 4. So horizontal asymptote is at y is at -4. So there it is. Now I have the shape of the graph. My graph looks like that. Domain, always all real numbers. In range, y is larger than -4. And this one is a decay because, again, it's getting flat. Okay. Last one is solving the equations. The rule is this. If you have the same base, like a, they're both base a. So if they're both the same base, then the exponents are equal. Like a to the x is equal to a to the y. Then x is equal to y. So in this case, you see how 3 is equal to 3 here? So you can just set the exponents to be equal to each other. 2x is equal to 10. Then, of course, x is equal to 5. If the bases are the same, you can set the exponents to be the same. That's the rule. Here, I have 81 is equal to 3 to the x plus 1 power. Now, the bases aren't the same, but I could change it to make the base the same, right? Find the root of 81, right? You break it down. 81 gives you what? 9 times 9, which is 3 times 3 times 3 times 3, right? So which is 3 to the 4th power. Now they match, right? The base is 3. So I can have 4 is equal to x plus 1. And solve for that, x is equal to 3. Here I have 4 and 8. Now I find the root of 8 is not 4. I can't match this. But I can find the root of both of them. 4 is 2 squared. 8 is 2 cubed. Okay, I just changed 4 to 2 squared and 8 to 2 cubed. Now the bases are the same, right? 2 and 2. So all I have is just the exponent. 2 times 2x minus 1 equals to 3 times x plus 3. You solve that equation, it gets all crazy, but x is equal to 11. This would be the easy part now. Okay? Here you have e. E is a number. Okay? When you solve for this, you don't really care what the base is as long as they're the same, right? All these have the same base e. So you don't really care what e is, but so you know. So you can graph this. On your homework, there's some graphing problem. Use e. Your calculator has a button for e. It'll tell you what that number is. But if you don't have a calculator that tells you, e is actually approximately 2.718. Just use 2.7 for e when you're graphing. Doesn't really matter, right? E is 2.7 when you're graphing. Anyways, so this one looks all crazy, but you can simplify this, okay? So e raised to the x raised to the 2, that means just e to the 2x. You simplify that. So it's e to the 2x. And then 1 over e cubed is equal to e to the -3 because you bring it to the other side of the fraction, you put a negative sign on it. Okay, rule of exponents. You guys got to know this. Okay, when you're multiplying two things with the same base, you add them. Add the exponent. So I have e to the 2x minus 3. Again, multiplying things of the same base, the exponents add 2x plus negative 3 is 2x minus 3. See, now you have the same base. You can set the exponents to be equal. So negative x squared is equal to 2x minus 3. Make it equal to 0. Factor it out and solve it. You get x is equal to negative 3 or x is equal to 1.